Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. It's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide. Hey, scientists may have just found a new planet that looks a lot like Earth, with a big icy catch. This world is about 150 light-years away, rocky, and circles a sun-like star on a schedule pretty close to ours. At first sight, it sounds promising, right? Well, slow down. There's a catch here. It might be insanely cold as Mars in the deep freeze. You see, HD 137010b, that's a mouthful, doesn't seem to be a gas ball, so we would probably be able to stand on its surface. It's a little bigger than Earth and goes around a star that's pretty similar to our Sun. This star is about 146 light-years away from our planet, which, in space terms, is close enough for scientists to study it instead of just, squinting at it. But what made people excited is the fact that this planet takes about 1 Earth year to go around its star. Now that's a big deal, because most exoplanets dash around their stars in days or weeks. Even better, this newly discovered one might sit right on the outer edge of the habitable zone, also called the Goldilocks zone. This region is not too hot and not too cold, which means that liquid water might exist on the planet if it has the right atmosphere. A big if, but still cool. Another thing that makes this planet extra special is how we see it. From Earth, it actually passes in front of its star. Imagine a tiny bug crawling across a flashlight beam. You got it. That makes it way easier for scientists to study things like its size, orbit, and maybe even what its atmosphere is made of. And if all of this checks out, It could be one of the best Earth-like planet candidates we've ever found. And now, the bad news. This planet does not get much sunlight. HD 137010b gets less than 1/3 of the heat and light Earth gets from the Sun. Even though its star is similar to our Sun, it's basically the Sun's quieter, dimmer cousin. You know, same type, lower wattage. What does that mean for the planet? It could be insanely cold. Scientists think the surface temperature might max out at around minus 90 degrees Fahrenheit. And that's not a grab-a-jacket cold, that's your face freezes right away cold. For comparison, Mars has an average temperature of around minus 85 degrees Fahrenheit. So this planet could actually be colder than Mars. A frozen desert, not to be confused with a frozen dessert, that looks like it gave up on life a long time ago. Another plot twist. This planet isn't officially a planet yet. At the moment, it's still labeled a candidate. Scientists usually confirm planets by watching them pass in front of their star over and over again. Every time that happens, the star dims just a little bit. But with this new space body, we've only seen one transit, a single 10-hour-long mini-eclipse, spotted during Kepler's second mission, called K2. Even with that one pass, astronomers could still learn a lot. They measured how long the planet's shadow took to cross the star, about 10 hours. For comparison, Earth takes about 13 hours to cross the Sun. Then, they plugged that into orbital models and estimated that the planet probably takes about a year to go around its star. That's impressive, but it's still not enough. Astronomers need to see that dip in starlight repeat on schedule to be sure it's really a planet and not some weird stellar wanderer. Unfortunately, this planet orbits far out, and those transits are rare. You don't get one every few days or weeks. You might have to wait a year or more for the next one. That's one of the big reasons Earth-like planets are so hard to find in the first place. So now, scientists are just hoping that other space telescopes can help out. NASA's TESS might catch another transit, or Europe's Cheops telescope could help pin it down. If neither of those catches it, we might have to wait for the next generation of space telescopes to get better data. Because even though this planet sounds like an ice cube in space, it's not totally doomed. If it has a thick atmosphere, especially if it's rich in carbon dioxide, it could trap heat really well, like a planet-sized winter coat. In that case, the planet might actually have a mild climate, or even liquid water on its surface. Well, based on computer models, scientists say there's about a 40% chance this distant world sits in the safe, conservative, habitable zone. A chance that is located in a more relaxed, optimistic habitable zone reaches 51%. But there's also a 50-50 chance that the planet is actually outside the habitable zone altogether. In other words, this planet is basically a cosmic coin toss. It could be a frozen wasteland, worse than Mars, a chilly, barely survivable world, or a watery planet hiding under a thick atmosphere. HD 137010b isn't the only place that has the potential to host human civilization in the future. In recent years, astronomers have been spotting new super-Earth planets orbiting remote stars. Now, checking our space vocabulary, super-Earth means a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. One of those planets is Gliese 667cc. It's just 22 light-years from Earth. But even though it seems pretty close, it's still around 129 trillion miles away from us. That's around 1.4 million times the average distance from the Earth to the Sun. So, very, very far. The planet itself is around 3.8 times as massive as Earth, and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares from its parent star. Then there's Kepler 22b. This world is way farther away than the previous world, more like 600 light-years away from our planet. It's larger than Earth and is about 2.5 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is pretty similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kinda similar to our Sun. But this star is smaller and colder than ours. Now, don't confuse this world with Kepler 69c. It lies a whopping 2,700 light-years away from us and is almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 242 days to complete one orbit. This makes its position in its system similar to that of Venus in our solar system. At the same time, this world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. As for our Venus, it's an extremely hostile place. You don't want to go there. A runaway greenhouse effect caused by an atmosphere that's about 96% carbon dioxide traps the heat. That pushes surface temperatures up to around 878 degrees Fahrenheit, which is hot enough to melt lead. On top of that, the air pressure is about 90 times stronger than that of Earth, and the whole planet is covered in thick clouds of corrosive sulfuric acid. Oh boy. Compared to our neighbor, TOI 733b seems like a pretty friendly world. This planet was found in 2023. It's floating 245 light-years away from Earth. The coolest thing about this planet is that it might have a massive ocean. According to scientists, this planet is likely to be completely covered with water. Does it mean there could be life on this super-Earth? Well, time will show. And who knows? Maybe soon we'll find even more planets that could become a new home for people looking to explore the universe. As for HD 137010b, the fact that it checks so many Earth-style boxes makes it a really interesting find. It's not a backup Earth yet, but it makes scientists stop and say, okay, this one's worth a closer look, or something similar. So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claim to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. we're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Barnard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Barnard Star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Barnard Star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Barnard Star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Barnard Star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Barnard Star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard Star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard Star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a fourth planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs like Barnard Star are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real Smartie. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation. Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away, They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered two other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
Take that giant space knife. Yes, you. It's time to visit the Sun and check what's inside. First, you're slicing through the corona, aka the Sun's wild hair. It's the Sun's super thin atmosphere, but don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the Sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and instant heat wave. It's like the Sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit, hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1,100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, Somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. Hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're gonna split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane, flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through? They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Wave's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small.
They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb Telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just 1 to 3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition. And the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator, because Earth spins a bit faster there. And this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.
Imagine a planet with no sun. Once it became unwanted in its own star systems and got ejected into the soulless emptiness of space. Or maybe it didn't even have its own star system. It was born lonely. I'm talking about a rogue planet. Such planets are also called orphans, nomads, unbound, and sunless. It all sounds pretty sad, doesn't it? The rogue planet in question doesn't have sunlight. The never-ending night reigns on its surfaces. No light means no warmth, and that's why there isn't any kind of life on this frozen world. But believe me, this isn't the scariest part. One day, a rogue planet might push Earth out of its cozy spot near the Sun. You see, we live in the habitable zone of our star. It means that our planet is such a distance from the Sun that water can't exist on its surface in its liquid form. But an interstellar intruder could mess it up for us. If a rogue planet somehow got into our solar system and we didn't manage to stop its imminent approach, it would likely crash into our beautiful blue planet. And then Earth could be pushed out of its orbit, retreating to an extreme orbit farther from the Sun. Now let's imagine what would happen to our world if a rogue planet the size of Mars collided with us. Most likely, people would react with panic and desperation. We've had a few sad examples of space intruders wiping more than 3/4 of all life forms off the face of the planet. One more similar event would be devastating. The immediate impact, pardon the pun, of such a collision would be truly catastrophic. It would lead to massive losses of life and destruction of huge areas of the planet. At first, people would focus on rescue and recovery efforts, but soon it would become obvious that the world is beyond salvation. The climate all over the planet would start getting colder and colder. Plus, the farther our planet would be from the Sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Well, that's rather grim. But what if humanity had foreseen this catastrophe and prepared for it in advance? What would our life look like, and where would we live after the cosmic disaster? If, by the time of the collision, people had already established a colony on Mars, we would probably have some time to leave Earth and set off for the Red Planet. But would it even be possible to transform this distant world so that it became capable of supporting human life? Oh, and it would no doubt be an enormous feat. You see, Mars is an extremely dangerous place to us. If you somehow teleported there without any protective suit, the gas in your blood would instantly turn into bubbles, which is not good. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, well, you get the picture. But if a rogue planet destroyed life on Earth, we'd have no choice. We would need to create a stronger magnetosphere on the Red Planet to shield it from the Sun's ultraviolet radiation. For the same reason, Mars would need a thicker atmosphere too. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. This air is not suitable for people. For humans to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the Red Planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Also, we would need some place to live. NASA has been experimenting with light inflatable habitats, but obviously, it wouldn't be a long-term solution. At the same time, it's incredibly expensive to deliver building materials to Mars, especially if we were pressed for time, escaping our poor collapsing Earth. So instead of shipping prefabricated construction elements to the Red Planet, we could grow them right on its surface. We could achieve this with the help of fungi and cyanobacteria. They can produce tons of biominerals like calcium carbonate, as well as biopolymers. They would be able to glue Martian rocky material covering bedrock into real building blocks. In other words, bricks on Mars would be growing on their own, and we'd only have to assemble them into different structures, like walls, floors, and even furniture. At the same time, such a young colony wouldn't be able to survive for more than a generation without getting more supplies from Earth. But, as you understand, this option would be unavailable. Then, maybe people would move to colonies located on numerous space stations located far enough from the impact event. In this case, we would be able to avoid the destruction. But such habitats would have to be large enough to support farming and medical facilities, power-generating factories, educational establishments, and many more. And it would be hard work to support such stations without necessary supplies, when a simple equipment breakdown could turn into an unsolvable problem. But let's imagine that our descendants decided to find Earth several thousand years later and succeeded. As you remember, our planet would have changed its position, hanging out way further from the Sun. Now, hopefully, Earth would have regained its magnetic field after the impact, as well as a little of its original atmosphere. But those who would return to Earth would need water, oxygen, and sufficient atmospheric pressure. And while the new pressure on the planet would probably be suitable for life, most likely there wouldn't be enough oxygen to support unaided breathing. To get a new supply of oxygen, people would need photosynthetic bacteria. Would we find any on the deserted planet? Probably yes. Most, or at least some bacteria would survive, maybe somewhere deep under the surface, maybe in the depths of the oceans if any remained on the planet. Tardigrades, the most indestructible animals on Earth, might also survive and greet people returning home. These tiny water bears can survive for up to 30 years without food, live in volcanoes, and even endure the vacuum of the cosmos. So these life forms, bacteria and tardigrades, could likely thrive and multiply without any predators to slow this process down. That's good to know, but what would we eat on the newly inhabited planet? Tardigrades are not a diet a person could live on. Well, we could still find some frozen seeds remaining on the planet, or we could keep them on our space stations. Earth's soil could be filled with nutrients remaining after the catastrophic events of the past. People would start planting seeds, trying to get used to the harsh conditions of life on the once deserted planet. And still, it would be better than soulless space stations. Luckily, a rogue planet is unlikely, not only to hit Earth, but even to come close to our planet. The appearances of such space travelers are extremely rare, and with how fast our technologies are developing these days, astronomers would spot such a large celestial object appearing in the neighborhood or even in the entire solar system. It would happen long before a rogue planet turned into a threat to our planet. If it got too close to us, we would use one of the methods developed to prevent asteroids from hitting the surface of the planet. There are quite a few. For example, a kinetic impactor. This technique requires hitting an asteroid to make it change its orbit until it's no longer a threat to our planet. Or we could use a gravity tractor asteroid deflection method. That's when a robotic probe meets a space rock, or in our case, a rogue planet, and accompanies it for a few months or even years. Over time, the spaceship's gravity starts affecting the space body, adjusting its trajectory. There's even spray painting celestial objects. I'm not kidding. Darker surfaces tend to reflect less light, while lighter reflect more. Toying with these features, we can make a rogue planet change its course. If we found enough paint to cover an entire planet, that is.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
2 billion people will be able to watch an asteroid the size of a skyscraper slide past Earth closer than many satellites. It's scheduled to happen in April 2029. Now, an asteroid of this size comes this close to our planet just once in 7,500 years, and it has to do with a strange interstellar visitor called 3I Atlas that recently shook scientific certainty. Here's how. The Atlas Survey System, a nickname for Asteroid Terrestrial Impact Last Alert System, that's a mouthful, well, it scans the sky every night looking for objects that might threaten Earth. When it first flagged 3I Atlas in 2025, it appeared as a faint smudge in telescope data, the kind of thing astronomers almost ignore because the sky is full of harmless junk. Then, scientists calculated its speed and direction and realized something was off. It wasn't bound to the sun like most comets and asteroids. Space objects usually follow clean curves dictated by gravity and sunlight. Sunlight heats a comet, ice turns to gas escapes, hey, I know all about that, and that tiny push slightly alters its path, like a slow leak nudging a balloon. 3I Atlas didn't just nudge, it lurched. It accelerated in ways that didn't line up neatly with heating models. It was moving too fast, on a path that screamed interstellar origin, which means it came from another star system entirely. It shifted direction slightly but persistently. That kind of motion means our models weren't telling the full story. Researchers figured out the object's structure must be unusual, like a fragile pile of rubble venting gas from unexpected pockets. It was also possible that its surface chemistry reacted differently to sunlight than anything we've seen before. And maybe it meant that tiny forces scientists usually ignored actually matter more than they thought. NASA and the ESA both emphasized that this thing, I'll just call it 3I, wasn't an extraterrestrial spacecraft, unlike what the internet crowd supposed. It sent no signals, there was no propulsion or artificial materials involved, just ice and dust. Nobody feared 3I would hit Earth, that part was clear, but they worried they wouldn't be able to predict its behavior. Space safety depends on knowing where things will be tomorrow, next year, and decades from now. 3I showed that even small bodies can act like trick coins instead of clean equations. And this knowledge is important to predict the behavior of our today's featured thingamabob, the asteroid Apophis. It got its nickname after the Egyptian deity of chaos, which is a bit worrying already. This bad boy will pass less than 20,000 miles away from Earth. Sounds like it's no biggie, but that is closer to our planet than the satellites that handle weather forecasting and global communications. Around 2 billion people living all over Africa and in Western Europe will be able to see it with their unaided eyes. Earth's gravity at that distance won't just wave hello, it will grab Apophis hard enough to potentially change its spin, crack its surface, or shift its internal structure. Scientists call these tidal forces. Think of it like squeezing a stress ball. You don't break it, but you don't leave it unchanged either. Now, before scientists studied 3I Atlas in detail, Apophis felt manageable, and its orbit looked pretty stable. Its flyby was supposed to be a controlled event. But when they learned more about 3I Atlas, scientists started framing 2029 differently, not as danger, but as a stress test. If Earth's gravity nudges Apophis even slightly, Models need to capture that in real time. That's why the European and Japanese space agencies developed the Ramses mission. It's a spacecraft packed with instruments and a Swiss-built high-resolution camera that will observe Apophis up close during the encounter. They want to see ruptures forming, dust shifting, spin rates changing. It's basically the asteroid equivalent of a human heart monitor. Now, the good news is that Apophis won't hit Earth in 2029, and scientists say that clearly. But safety depends on predictability, and predictability took a hit when 3i Atlas misbehaved. So the scientists are now watching Apophis closely to test their assumptions in the safest way possible, with a known object, a known time, and every telescope pointed straight at it. Of course, they didn't take their eyes off 3i Atlas either. One of NASA's newest spacecraft, Europa Clipper, is cruising toward Jupiter right now, with a long trip ahead of it. On the way, scientists realized they had a perfect chance to point their instruments at this interstellar comet. From about 102 million miles away, Europa Clipper turned its camera and watched 3i Atlas drift by. What it captured isn't something your eyes could ever see. The image came from an ultraviolet instrument designed to study Jupiter's icy moons, not comets, and it observed 3i Atlas for 7 straight hours. Ultraviolet light reveals gases and elements that stay completely invisible in normal photos. It's a way for scientists to see the comet's chemistry in action instead of just its shape. That glowing cloud around the comet, called the coma, tells us what's escaping from the ice as sunlight hits it. By studying how those gases spread and move, scientists can learn what 3i Atlas is made of and how active it really is. Now, so far, scientists have had a chance to find some pretty unusual things about its chemistry. Radio telescopes in the Atacama Desert locked onto the comet and picked up clear signals from methanol and hydrogen cyanide. These two molecules that sound boring and somewhat deadly until you realize they sit right at the entrance ramp to life chemistry. These weren't tiny traces either. 3i Atlas pumped out methanol at levels that jumped sharply as it approached the Sun. They spiked right where water ice starts to vaporize. Compared to most comets humans have ever measured, this thing came loaded. Its methanol to hydrogen cyanide ratio landed among the most enriched values ever seen. This doesn't mean that 3i Atlas carries life, or bacteria, or anything even remotely alive. But these molecules matter because chemistry doesn't jump straight from rock to organism. Life, at least the kind we understand, builds itself step by step. Hydrogen cyanide plays a key role in forming amino acids, the Lego bricks of proteins. Methanol acts like a chemical multi-tool that helps assemble more complex molecules, like sugars and the precursors to DNA and RNA. On 3i Atlas, methanol made up about 8% of its vapor, and that's roughly 4 times what we usually see in solar system comets. Another cool part is where these ingredients for life came from. 3i Atlas formed around another star inside another planetary system, under conditions we can only guess at. And yet, it shows up carrying the same basic toolkit that life on Earth relies on. That lines up with an old idea scientists have kicked around for decades. Comets and asteroids might act like delivery trucks, scattering water and organic molecules across young planets. Earth may not have invented its chemistry from scratch. It may have inherited it. Now, before 3i Atlas, we had only confirmed 2 interstellar visitors, Oumuamua in 2017 and 2i Borisov in 2019. Oumuamua freaked everyone out because it didn't look like a normal comet at all. It had no obvious tail, showed weird acceleration, and was of a cigar-like shape. So the internet went wild with crazy extraterrestrial theories. Borisov felt like a relief by comparison. It behaved exactly how a comet should, growing a coma, releasing gas, and cruising through the solar system without drama. Some people feared Borisov could collide with Earth or disrupt planetary orbits. But it flew by smoothly, boring even, like a guest who followed every house rule. Borisov reassured scientists that interstellar objects could be predictable. 3i Atlas shattered that calm and showed us they could quietly undermine confidence without causing harm. Apophis now stands as the ultimate test run. Scientists already know it won't hurt us, but then again, the examples of interstellar visitors show how little we actually know about them. It indicates that space has its own, mostly unknown rules, is highly hostile to human life, and it's not very polite either. It doesn't announce surprises in advance, and the better we know about it, the better we can be prepared for these surprises.